How you doing, everybody? Sean O'Kane here with ChipEstimate.com and Chip Estimate TV. We're here at the 55th Design Automation Conference in San Francisco. Let me tell you just a little bit about Chip Estimate and what we do. Chip Estimate is an IP portal, an ecosystem comprised of over 200 of the world's largest IP suppliers and foundries, and we're all working together to help this worldwide design community become more successful and profitable by searching and exploring the most up-to-date silicon-proven IP available on the market, which happens to be also listed on ChipEstimate.com. With me today is Andrew Hopkins, Director of System Technology at ARM. Thank you for taking a little bit of time with us today.
You're welcome.
Okay, and by the way, ARM has their complete IP catalog listed on ChipEstimate.com, as well as our videos and their white papers and technical articles. So that's a nice search for information as well. So ARM is very experienced with both security and functional safety, making its products very well placed to enable success in the automotive industry, which we'll touch on, industrial and other markets where both functional safety and security are essential and paramount. Our topic today is the myths of system resilience. What are the myths of system resilience?
Well, there's really two myths that we see. So one of those myths is that when you're trying to build up a chip, that if you develop IP such as a processor or a DMA that issues transactions into the bus, that you can protect those transactions by launching them with something like an error correcting code or detection code that will pass through the interconnect and then arrive at the destination like a memory or a peripheral of some kind. And there's a great belief based on kind of historic ways that systems were built that that's a good way to protect the overall system. And it's what we would call in ARM a monolithic approach, because it's relying on one piece of IP essentially to protect other pieces of IP. But and so that's kind of a flawed approach, because when you generate the IP that issues the transactions, you don't necessarily have any understanding of how complex the other pieces of IP in the system are. They might be of low complexity, which requires a kind of low strength resilience solution, or they may be of very high complexity that requires a much stronger capability. And so one size never fits all. Right. And that kind of leads me into the kind of second myth, and that's that if you just look at one piece in isolation, that it will enable you to build a resilient system overall, that if everybody just looks at their individual part without considering the whole system, that if you build things up together as kind of building blocks, that you end up with a kind of strong wall of kind of defense against the things that could go wrong inside the device. But actually that's also another myth, because what's really needed is something that is for there to be a system level view. Because ultimately it's the system that has to be safe or resilient, not just the individual pieces.
So ARM offers a wide range of security IP. And how does ARM think about the system resilience and how it confronts, how it is confronted, and does this involve ARM Trust Zone support?
So that's a very good question. I mean, so firstly, functional safety and security, they generally go hand in hand in a system, and they're both forms of resilience. There's various kind of obviously attacks that can happen on the security side, and on the safety side there could be defects, permanent faults, transient faults, etc. And so it's very important that the system is both safe and secure, and they both need to be considered in a kind of holistic, system-wide kind of way. But actually, the two can also conflict, which is also why they have to be considered at a kind of big picture level rather than focusing on the individual blocks. And so in terms of how does that all fit with Trust Zone? Well, Trust Zone is a really important part of ARM's security solution, and it's one of the key ingredients that we have in order to enable chip companies to fulfill the requirements of our recently launched platform security architecture, which provides a framework for all classes of device, from IoT to automotive, to guide organisations in analysing their systems and actually then building out the capability needed to have secure devices and systems that can be kind of standard across everywhere. But of course, going back to the functional safety kind of aspects, that also has to be right as well, particularly for automotive. And so that's why if the monolithic approach isn't the right way to go, how should we go about that? Well, the way we see that kind of working, and indeed we're not the only organisation in the industry that does that, has kind of reached this conclusion. Our interconnect partners feel quite strongly about this as well. Actually what's needed is a modular approach.
So let's continue with that in the automotive theme. And I know you just touched on a little bit of this, but in addressing the complex automotive application requirements, developers encounter integration challenges.
That's exactly right. And because
I just want to know what the benefits are to the modular approach.
Absolutely. So the benefits of the modular approach are that you can arrive at a highly resilient system that is meets the requirements that's needed for functional safety in automotive, but also resilience for other things like infrastructure, in a way that is most cost effective. So whether it's a small system or a large system, you now have a situation where each part has been developed in such a way that it has the right size of capability. But as we said before, you need to do more than just look at each piece. You need to look at the whole system. So where ARM can step in is that we can look at the way these components are joined together, and we do that through the ARM AMBER specifications.
And that's how you enable it.
And exactly. So ultimately, when we're going to enable the industry, we need to show leadership, and which is why we're currently working on extensions to those AMBER specifications to make the integration between IP much simpler, much easier, and actually make it consistent, so that any IP vendor can create IP that's resilient and for functional safety, and it can then interoperate with other vendors' IP.
Very nice. Very nice. Well, I really appreciate you stopping by today. This is the final day of Design Automation Conference. We're streaming live on Facebook, and again, thank you to ARM and Andrew Hopkins. For Andrew, my name is Sean O'Kane, and we'll see you next time on Chip Estimate TV. Thank you.
Thank you. It's great to be here.
Yes.